Hi everyone, Alex is here. Let's check today ESP32 weather example. But before checking that, let's discover about IoT. So IoT is Internet of Things. So basically, when you have any of your devices right now, it's something similar to IoT. So basically, when you have your phone, for example, or watch that are connected to Wi-Fi, Bluetooth, or connected with your devices, it's all about that. So basically, it's when you have, for example, some of your physical chips, systems, and you're programming them. So you're connecting to them, you're working on them, you should really rely on physics, on electronics, so that's it. And when we're talking about IoT, so before that, we should always work on hardware firstly. But right now, you can work online with a couple of your online tools for working on systems and working with chips. So let's talk about today things that we have. So we have, for example, Arduino, we have Raspberry Pi, Pico, we have STM32 and SP32 that we'll be using today, the last one. So basically you can have them in reality. I don't have them right now with me. And with them you can create a bunch of the system, you can create basically everything that you see is created on that. So sensors, even phones, but that's completely different system. Or for example, you wanted to work with some device that will discover ground, some minerals, or how good is that, everything. And that is just these chips, these systems that you're programming. So before that you have been doing that offline, so you have taken them, connect to them, with computer have been programming them, they have been lighting, not lighting, something was spinning, but all of that was related on physics. So physics plus electronics, all of that have been connected. So if you wanted to work with IoT, you should really rely on physics and electronics, on Python and C or C++, and also you should work with cloud and know internet protocols and working with MQTT, for example. We'll be talking about that. So that's basically what you should do, should have and understand. Right now we'll be using virtual hardware. So why? Firstly, it's cheap, it's easy, and it's fast. So when you're trying to create such things, firstly, nearly every time you're trying to check that online with your internet tools, or if you have a big company, you can probably have software for such chips that will be created by your oven. So it's really increases how how it will be working, because if, for example, you are a big company and you wanted to create a new chip or something like that, and you're creating that and then testing, that will be fail. You should create it online, test it in a couple of times, and then make it real to test that in real. Why so? Because basically all of such chips that are working the same, they're using the same hardware that you'll be using online with an app or online with the website, so we'll be using the simplest versions. So they just have the same code and they will be working the same, and you will be able to see how does it work. So you'll be able to test it instantly. Because, for example, we'll be checking weather app today, and here we won't be able to see the difference. For example, to one room we should go to the different places and then we'll be see the room, but it's not so easy to do as I'm recording that. So that's why we're using online tools, and they will be using and working the same. That's the baseline of creating such programs, so you will be working virtually that, and that's really cool right now. So that's first of what you should know. And creating all of that smart homes and etc. It's all IoT. Basically, drones, cameras, everything. That's what you should understand. And let's quickly decide about how to program this. So basically you'll be using your MicroPython or C or C++. You can use different programming languages, so there are a lot of such chips, a lot of such systems, and a lot of programming languages also. But basically you'll be using these three. So MicroPython, it's the simplest one, so it's just simple, easy, relied on. It's easygoing. But if you wanted to work with something more serious, you'll be working with C probably, maybe C++. It depends on the company and on the system that you're creating. Why? Because there are no limits, and it's incredibly optimized. If it's important every millisecond of that, C or C++ you'll be working on. MicroPython is to create simple, fast, reliable system, but the keyword is fast. Yeah, that's the truth that you should understand on that. And let's discover about these four systems. How does it work? So Arduino, it's basically easy for beginners. It has a great community. Really, I think if you're starting to do that and you like that, buy Arduino real. Like first you try that virtual, then buy that real if you still like that, because it will increase your understandability of working in this sphere. We have Raspberry Pi. It's quite good with MicroPython, like incredibly. It is using on real projects. Arduino is not so, it's more for small projects, maybe some small stuff to create, or more basically it's for education. But Raspberry Pi, for example, it can be used for projects that should cost as less as possible. Raspberry Pi can be taken. That will be a little bit more powerful projects. And we have, for example, SMT32. It's totally different thing. It's productive. It's basically for corporations and companies that are creating something for them unique. So it's effectivity, it's reliability, but it's professionally standard. And it'll be quite hard to start on that 100%. But when you have been working with such things and you're going to the next level, SMT32, it will be definitely the way where you're all going to. And ENT32 is ideal middle between, for example, Raspberry Pi and SMT32. It's not so hard as the second one and not so easy as the first one. It's ideal. And it's ideal especially if you're working with Bluetooth and Wi-Fi, because it's totally rely on that, and it has two core processor, as I remember, that helps you to work with a couple of tasks at once, so you'll be also discovering how to do that. So that's ideal case in our way, so we'll be able to discover how to work on that. And let's understand. So we know how to go to this sphere, what you should basically know. But in general, you can just start working with no Python and go ahead and discover physics and etc. By the way, you're going to on this way. So you have your chips, how to do work that. We have virtual assistant that we'll be discovering today. And what we also should have. So as I told you, you should understand the system of messaging and how to work with MQTT. And let's talk about that. So MQTT is message quoting telemetry transport. What's that? It's analog for our HTTP, but totally different way. MQTT was created basically for IoT, so it's maximally easy. It's basically to work totally different than HTTP, for example. And also they handles less information than HTTP. So an idea in MQTT is the next. We have a publisher, we have broker, and we have subscribers. Something similar to observers in Angular. So publisher is, for example, our device with weather. We're sending via Wi-Fi to the broker is the server, for example, as HTTP is sending requests from your web page to the backend. some information, and then from this broker, it spreads. So broker sends information to a couple of devices. For example, if you have weather, if weather is below, for example, this temperature, the lights will be on. System of the weather is your publisher. Broker is the server. It's always the server. Sometimes the server can be your device, for example, as Apple is creating that, but that's totally different thing. Then subscribers is a lot of your devices. For example, lights, or for example, TV, or another thing. So it's subscribers. What they're doing is like a running server. It's just waiting anything that will be connected to that. So it is waiting for a request or any request from your server. And when server sends that, it automatically discovers what the server has taken and doing the stuff that was programmed. And based on that, we can make a couple of different things. So we can have topics. That means that when one of our devices can handle multiple of things. And we can discover these sensors as like folders inside, and we can work with hashtags, with plus, for example, to discover multiple of the things. It doesn't matter for right now. We can make a video later about that. But the main thing here that you should understand is how does it transfer the data? How does it sense that? That's the key thing here. And also we have quality of service. So basically there are, like QoS, quality of service. So we have 0, we have 1, and we have 2. 0, it means that it sends only one time without any confirmation from the broker. So it's much easier to hack this, honestly speaking. But it is using for any non-crucial data. So when like something open, like server, like some device is sending open data or taking open data, basically sense, it means that it's not crucial data. We have one, QoS 1. It means that it sends at least one time. So it guarantees that the message will be delivered. So then it takes information from the server, sends back that it was taken, and it is confirming that it is right. It is less fast, but it's for most of the things you'll be using this one. And QoS2. The problem with QoS1 is that sometimes you can have duplicated data. When you'll be working on that, you'll discover. But QoS2 is like checks a couple of times if the message was only one. And it's the most slow, and it's the most hard thing to work on, but it's the most reliable. So for all the sensitive data, you'll be using this one. And it's just too general for you to discover that there is a thing that calls quality of service, but we'll be talking about it later. So that's what we have with MQTT. I think that, the only one thing is with cloud. So basically the server, the cloud will be, for example, Azure IoT or AVC IoT or your own server. So basically it's the specific servers that are working only with IoT. So it makes reliability on them. It works with raw data, and you should try them out to discover how does it work. But basically, an idea of this service is that they're only working with your IoT devices, and there guarantees them and you that the broker, like subscribers and publishers, are only that they have been selected and they cannot be changed. So that's why a lot of the stuff right now can be hacked, as you think. Like, you think that it's easier to create, for example, a similar stuff, or to take, for example, projector and to have access to its internal system by, for example, duplicating that, all of the process, all of the processor, all the data inside. You probably not will be working in such a way, because it will have a huge validation on AVC and Azure side. And it's quite hard to tell in this video just for a couple of seconds or minutes. Better to have different video about such clouds, but that's an idea, so the broker will be this server. That's all about how does it should work. And let's go to our example. So right now we're on the website that calls Wokwi, and here we can work with our processors examples. So here we see Raspberry Pi Pico, STM32, Arduino, and we'll be working with ESP32. Also we have Wokwi Pro here, like a couple of different other stuff you can discover here, but we'll be working with ESP32, we're going here, and then we're going to Azure Logger. So here are a lot of preset projects and also start template, and we'll be working with their MQTT Azure Logger. So for you to understand how all the system works. So to discover that, first we have main.py and we have diagram.json just to know how does it work. We have libraries here not installed, but we'll be discovering we'll see libraries here. So what we can do, we're just hitting start the simulation, and you see how does it will work. So basically, it first takes some configurations of your projects, then it's connect to Wi-Fi, then it says that it's connecting to MQTT server that I was telling to you that they're using, and let's work with our measuring weather conditions. So reporting to MQTT, so it is sending to our server that we have humidity 40 and everything 24, and then no changes. So it checks that, for example, every second or something like that. And here you can see time, powerfulness, or something like that. The Wi-Fi connection is just gateway to Wokwi Wi-Fi guest will be. I will say you that in the code how does it work. We can pause, stop that, but let's discover how it will work. We're clicking on this thing, and we see here temperature, humidity, that is default. Let's change it to 24 and 30, for example, approximately, or humidity, and we'll see the difference here. Let's check temperature. You see temperature is updated and instantly send it to our MQTT. Then there is no changes. Humidity, it was changed, and the data have been going there. So that's how does it work in a simple way, and you can discover what should be connected where and why electronics and physics will tell you, and also the instructions how does it should work. So you can see here a lot of such things that you can connect by your oven, and what you're connecting where, how does it work. Like for example, this thing is blinding, is lighting, so it works. It's the easiest way how to show you that it works. And now I hope that you see why we should do that online. So it's quite good project, like it's quite good created, it's quite good working on it, and you can understand how all such things work just from online, like nothing to install, and even the code is here, and you can even change it as you wanted to. You can even sign up to have your own account here. That's how it works. Let's stop the simulation. What do we see here? First, we're importing some data. So network is like to work with our network from the Python. Time, machine, from we're importing pin. It means that we're working with especially this machine and for our specific pin. And it's like pre-import data. We have GHT, so it's on what will be working. This is our machine. This is the pin from that. And UJSON is for working with our JSON that will be coming from our messages. So when we're receiving messages, UJSON will take them and will then discover that we're taking the data from sensors, and then we'll put them into the JSON. And to create this JSON, we're using UJSON. So it will convert our object to JSON. And we have our MQTT client from this library. Yeah, the next time I think I will say a little bit more about how to work with all the things. So we have our client ID, broker, username, password topic. It's basically the preset that we'll be using for connection to any of our broker, for any of that. So firstly, we're having sensor that we're working on. Then we have our network And what this thing do? So we're trying to connect to our Wi-Fi. So what we'll be using here? Active true, it will run like that. We should use the Wi-Fi, and we are connecting to Wokwi Wi-Fi guest without the password. It's just the pre-installed Wi-Fi for this solution. It will be working that, for example, with different systems, this won't work. And basically, when you have your project physically, you should write here your normal Wi-Fi and the password to that. And this one means that we're trying to connect, and you can discover it here. So when we have connected, it means that we're connected, and each 0.1 second is just a dot to be connected to the server. So that's why this one connects into Wi-Fi. With one that will be working on that, with connecting to Wi-Fi. That's how it works here. Then we're connecting to the server. How this will work? We're just taking our client, object of the client, client ID, broker, user, password, and we're connecting. And if it will be connected, incredibly, we can go further. Then we have previous weather variable. Why we have so? It's extremely important to send only important things to the cloud. So when we have the same weather, and we will be sending that, it will be the problem, because we're taking a lot of the data and a lot of the powerfulness of your IoT to send these things. So you should, for example, a lot of the things have their battery. And one of the things of optimizing the battery is not sending requests that aren't needed right now. So we're taking, we're having while true, you know that it will mean so that it will be working every time. So we're taking sensors measures, and these sensors, they will instantly have like what I'm telling you here. And things, so we have instantly working with our sensor, and like where it will be connected. So it just takes that, it measures the thing, and then we're creating the message. So we are creating just JSON example with our temperature and our humidity. Then we're checking if it is not equal to the previous one. Previous is empty. Then if it's not that, we're updating that, and we are reporting such changes to Wokwi Weather, and we're publishing that. Another client where we have Weather 2, we can not publish, we can subscribe on that, and we can receive the information. So that's how it will work. But here we have just a publishing that message, and then we're just equaling previous weather to the new message. And we're waiting every 1 second. Why? Because without that it will be working too much, as we're not should do. And sometimes some sensors, if you have seen, they have a delay, and this delay is for optimizing, for example, battery. It's important. So that's how it works. It's quite easy example. I hope that you understand how does it work, and you can discover more examples in this website. And we'll go to the diagram. We'll discover a little bit more information about the device that we're using, how does it using. So it's not so important for us right now, but the main part, how does it connect to Wi-Fi, connect to the server, take the measures and updates them. That's the crucial that you should know, and that's not so hard as you see. It's like quite 40 lines of code, and there are one process, two process, three process, four process. Like we're connecting to Wi-Fi, connecting to the MQTT client, taking the data and updating them. 4 things during 40 lines of code. Quite fast, and a lot of printing. So without them, it will be much faster. I hope that you understand how does it work. That's why we're using Python, and that will help you to understand how you should work with them later with your own system. Thanks everyone to be here. I really appreciate you watching this video and taking your thoughts, comments. I really wanted to improve our channel, so you'll have more interesting and more exciting news, and you'll understand how does it all things works. So please hit the like, hit the subscribe button, and also write the comments about what you wanted to see next and what do you think about the video. Thanks everyone for watching this one. See you in the next one. Bye.